Want to build a serverless email processing system that scales automatically, stays private, and never loses a message? I'll show you how step by step. Hey guys, I'm Ali Khamis, and today I'll be breaking down a real-world serverless backend that I have built on AWS that collects emails, validates them, and stores them securely and reliably without managing a single server. If you're a developer, stick around. This architecture scales automatically and is production ready. First, let's talk about Amazon CloudFront. CloudFront is AWS's content delivery network, or CDN. It sits at the edge of AWS, close to your users globally, so requests are delivered faster. It also handles TLS termination, offers low latency performance, and protects your backend with built-in DDoS protection. This architecture, CloudFront, is the public-facing entry point. It forwards users' requests securely to API gateway, hiding our backend and adding an extra layer of security and performance. Next is API gateway. API gateway allows you to expose REST or HTTP APIs. It integrates seamlessly with Lambda functions, so you can handle requests without managing servers. Here, API gateway receives requests from CloudFront and forwards them to the validation Lambda. It acts as our managed API layer, providing request validation, throttling, and security without touching the VPC directly. Now let's discuss the VPC and private subnets. A VPC, or virtual private cloud, is your own isolated network in AWS. Private subnets are subnets with no internet access, making them ideal for secure workloads. Both our Lambda functions run inside these private subnets. This ensures that all outbound AWS service access goes through the VPC endpoints, improving security and reducing attack surface. No NAT gateway, no public exposure, just fully private internal communication. AWS Lambda lets you run code without managing servers. You only pay for the compute you use. Lambdas can also run inside a VPC, allowing private access to other resources. The first Lambda is invoked synchronously by API gateway. Its job is to validate incoming email data, apply business rules, and sanitize inputs. Once validated, it pushes the message to our first in first out SQS queue. Notice that this Lambda does not write to DynamoDB directly. It decouples validation from persistence. Amazon SQS, or Simple Queue Service, is a fully managed message queue. There are standard queues and first in first out queues. First in first out queues guarantees exactly once processing, strict ordering, deduplication. Here the first in first out queue acts as a buffer between validation and persistence. It guarantees that the emails are processed in the exact order they arrived in and prevents duplicate inserts into DynamoDB. It also smooths out spikes in traffic, ensuring the worker Lambda can scale safely. The second Lambda is triggered asynchronously by the first in first out queue. Lambda integrates natively with SQS. Each message triggers the function, and scaling is handled automatically based on the queue depth. This worker Lambda processes each message per message group, inserting validated emails into DynamoDB. If there is a failure, SQS automatically retries, ensuring reliable processing. Amazon DynamoDB is a serverless NoSQL database. It provides low latency reads and writes, scales automatically, and is fully managed. Here DynamoDB is our final storage layer. The worker Lambda writes validated email records directly to DynamoDB over a private VPC endpoint, ensuring all traffic remains internal and secure. VPC endpoints allow private communication between your VPC and AWS services without touching the public internet. Interface endpoints connect to services like SQS. Gateway endpoints connect to services like DynamoDB. In this setup, SQS is accessed via an interface VPC endpoint. DynamoDB is accessed via a gateway VPC endpoint. No internet gateway, no NAT gateway. All traffic stays on the AWS backbone network, improving security and reliability. Let's recap why this architecture works so well. Fully serverless and secure. First in first out queue guarantees ordered, reliable processing. Lambda scales automatically with traffic. DynamoDB and VPC endpoints keep data private and fast. This is a production-ready architecture that scales effortlessly and follows AWS best practices. If you want, I can also show you a live walkthrough with CloudFormation or CDK, so you can deploy this architecture yourself. Comment below if you want that.